Assalamu alaikum. My name is Mariam. I am 14 years old and my passion project is astronomy. If you do not know what astronomy is and you're not familiar with it, it is the study of celestial objects. My driving question is how can I conclude this term with knowledge of celestial objects and their evolution? First of all, what is celestial objects?
I know.
Go right ahead.
Thanks, Mariam. Basically, celestial objects are anything outside Earth's atmosphere, like moons, comets, asteroids, and planets. Oh, hi, Saturn.
On the topic of Saturn, why does Saturn have a ring?
Could God like to tell what you put a ring
No.
on?
Saturn's rings likely formed due to comets, asteroids, and even moons which broke up in orbit around Saturn due to Saturn's very strong gravitational pull. Scientists say these rings formed 160 million years ago.
Which planet in the solar system has the most moons? So we have 8 planets in our solar system. They are separated into 2 different groups, terrestrial planets and Jovian planets. Terrestrial planets are planets primarily made of rocky material and they have few or no moons. As example, Mercury and Venus have 0 moons because of their proximity to the Sun's gravity. Mercury and Venus are unable to hold their own moons. Earth has 1 moon. Beyond Earth, our planet's moon is the only place where humans have set foot. Mars has 2 moons. Mars's moons may have been asteroids floating through space before they were captured by the planet's gravitational pull. The Jovian planets, or ice and gas giants of the outer solar system, have many more moons. Neptune has 14 moons. 13 were confirmed and one is provisional. In keeping with Neptune's maritime namesake, most of its moons are named after sea gods and nymphs in Greek mythology. Uranus has 27 confirmed moons. Uranus's moons are named after characters from the works of William Shakespeare and Alexander Pope. Saturn has 61 moons. 53 were confirmed and 8 are provisional. Saturn's largest moon, Titan, is the solar system's only moon with clouds and an atmosphere. Jupiter has 69 moons. 53 were confirmed and 16 are provisional. Jupiter's largest moon, Ganymede, is also the largest satellite in the entire solar system. At the edge of the solar system, Pluto pushes the boundaries of our understanding of the universe. Nestled within the far-flung Kuiper belt, the dwarf planet is believed to be one of the countless celestial objects left over from the formation of the solar system. While it is one of the Kuiper belt's largest bodies, Pluto is only half as wide as the United States and about 2/3 the size of Earth's moon, making it easily dwarfed by the solar system's 8 true planets. This tiny world takes 248 Earth years to orbit the Sun, and it does so from an average distance of over 3.6 billion miles, or 40 times the space between Earth and the Sun. Such a distance from the solar system's main source of heat causes extreme temperatures on the dwarf planet's surface. Between negative 375 and negative 400 degrees Fahrenheit. The frigid temperatures play a crucial role in shaping the geological composition of Pluto. Its core, likely made of rock and metals, is encapsulated by a mantle of ice. The dwarf planet's crust is made of rock material and other types of ice such as frozen carbon monoxide, methane, and nitrogen. These frozen gases over Pluto's approximately 6.4 million square miles of surface area, which is barely the size of Russia, the icy terrain is much like Earth's, with polar ice caps, valleys, plains, and craters. It even has glaciers made of frozen nitrogen, and frozen water on the surface makes giant floating mountains. Our solar system is one of over 500 known solar systems in the entire Milky Way galaxy. The solar system came into being about 4.5 billion years ago when a cloud of interstellar gas and dust collapsed, resulting in a solar nebula, a swirling disk of material that collided to form the solar system. The solar system is located in the Milky Way's Orion star cluster. Only 15% of stars in the galaxy host planetary systems. Revolving around the Sun are 8 planets. The planets are divided into 2 categories based on their composition: terrestrial and Jovian. Terrestrial planets, including Mercury, Venus, Earth, and Mars, are primarily made of rocky material. Their surfaces are solid. They don't have ring systems. They have very few or no moons, and they are relatively small. The smallest and closest to the Sun is Mercury, which has the shortest orbit in the solar system, at about 3 Earth months. Venus is the hottest planet, with temperatures of up to 867 degrees Fahrenheit due to an atmosphere of carbon dioxide and extensive lava flows. Next to this world of fire is a world of water, Earth. The water systems on this planet help create the only known environment in the universe capable of sustaining life. The last of the terrestrial planets, Mars, might have also supported life about 3.7 billion years ago, when the planet had a watery surface and moist atmosphere. Beyond the 4 terrestrial planets of the inner solar system lie the Jovian planets of our outer solar system. The Jovian planets include gas giants, Jupiter and Saturn, and ice giants, Uranus and Neptune. The gas giants are predominantly made of helium and hydrogen, and the ice giants also contain a rock ice and a liquid mixture of water, methane, and ammonia. All 4 Jovian planets have multiple moons. They have sport ring systems, they have no solid surface, and are immense. The largest Jovian is also the largest planet in the solar system, Jupiter. Nearby is Saturn, the solar system's second largest planet. Its signature rings are wide enough to fit between Earth and the Moon, but are barely a kilometer thick. Past Saturn are the ice giants, Uranus and Neptune. The slightly bigger of these ice giants, Uranus, is famous for rotating on its side. Next to Uranus is Neptune, the outermost planet in the solar system, and also one of the coldest. Orbiting the terrestrial planets is the asteroid belt, a flat disk of a rocky object full of remnants from the solar system's formation. From microscopic dust particles to the largest known object, the dwarf planet Ceres. Another disk of space debris lies much further out and orbits the Jovian planets, the icy Kuiper belt. Apart from asteroids, the Kuiper belt is also home to dwarf planets such as Pluto, and is the birthplace of many comets. Beyond the Kuiper belt is the Oort cloud, a vast spherical collection of icy debris. It is considered the edge of the solar system, since that is where the gravitational and physical influence of the Sun end. Our solar system's particular configuration of planets and other celestial objects, all revolving around a life-giving star, make it a special place to call home.
The Sun is the center of our solar system. Everything revolves around it due to its gravity. It is 4.5 billion years old. It is 865,000 miles in diameter, which is about 109 times the diameter of Earth. The Sun is so massive that 1.3 million Earths could fit inside of it. The Sun is 93 million miles away from us, and it's the only star in our solar system. Let's do some anatomy of the Sun. The inner layers of the Sun are the core, which is the hottest at 10 million Kelvin, which is around 10 million Celsius. The radiative zone and the convection zone are also inner layers of the Sun. The outer layers of the Sun are the chromosphere and the corona, which is visible during a solar eclipse. The photosphere is also one of the outer layers of the Sun. This part we can see from Earth.
Why did the Sun go to school? To get a little brighter.
No, actually a billion years from now, it will shine 10% brighter, still enough to heat up the Earth's surface above the boiling point of water.
Black holes are among the most fascinating objects in our universe and also the most mysterious. A black hole is a region in space where the force of gravity is so strong, not even light, the fastest known entity in our universe, can escape. The boundary of a black hole is called the event horizon, a point of no return beyond which we truly cannot see. When something crosses the event horizon, it collapses into the black hole singularity, an infinitely small, infinitely dense point where space, time, and the laws of physics no longer apply. Scientists have theorized several types of black holes, with stellar and supermassive black holes being the most common. Stellar black holes form when massive stars die and collapse. They are roughly 10 to 20 times the mass of our Sun, and scattered throughout the universe. There could be millions of these stellar black holes in the Milky Way alone. Supermassive black holes are giants by comparison, measuring millions, even billions of times more massive than our Sun. Scientists can only guess how they form, but we do know they exist at the center of just about every large galaxy, including ours. Sagittarius A, the supermassive black hole at the center of the Milky Way, has a mass of roughly 4 million suns and has a diameter about the distance between the Earth and our Sun. Black holes remained largely unknown until the 20th century. In 1916, using Einstein's general theory of relativity, a German physicist named Karl Schwarzschild calculated that any mass can become a black hole if it were compressed tightly enough. But it wasn't until 1971, when theory became reality, astronomers studying the constellation Cygnus discovered the first black hole. An untold number of black holes are scattered throughout the universe, constantly warping space and time, altering entire galaxies, and endlessly inspiring both scientists and our collective imagination.
As we conclude this cosmic escapade, remember, in the vastness of the universe, there's always space for more stargazers and fewer space invaders. Keep your telescopes pointed towards the sky, your minds open to the wonders of the universe, and your puns about Pluto's identity crisis on ice. Until our next orbit intersects, keep exploring, keep learning, and may your understanding of the universe be as boundless as space itself.